Hello children, today we are going to discuss about second chapter of our grade 10 is polynomials. What else are the topics there in polynomials? Because in grade 9 also we discuss the same thing. The extension are one level ahead or two levels ahead are given in our grade 10, and we need to discuss very important and interesting concepts which are being given in our polynomials topic, right. First of all, let us try to recall what is meant by a polynomial. What is the definition of a polynomial? So, in fact, we learnt it in grade 9, but just to recall what is the definition of a polynomial. Okay. So, let us consider an algebraic expression, let it be in terms of x, which is equal to a0 x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus so on plus an, where a0 is not equal to 0, a1, a2 and so on an are different real numbers, and moreover n, n minus 1, n minus 2 and so on are non-negative integers. What do you mean by non-negative integers? They are whole numbers. If an algebraic expression p of x is equal to a0 x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus so on plus an, in this algebraic expression in terms of one variable, the coefficients are a0, a1, a2 and so on an. They are coefficients of various terms of x. All coefficients are real numbers, and n, n minus 1, n minus 2 and so on, they are various powers of x. These various powers of x are non-negative integers. Then this algebraic expression is said to be a real polynomial, where a0 is not equal to 0. Why a0 is not equal to 0, and what do you call that a0? a0 is called as leading coefficient, means the coefficient of highest powered term is said to be the leading coefficient. So, here leading coefficient is not supposed to be 0. What happens when leading coefficient is equal to 0? Then 0 into x to the power of n is equal to 0, means there is no x to the power of n term. If there is no x to the power of n term, then we cannot call this as nth degree polynomial. The highest power of a polynomial is said to be degree, right? So, then you cannot call it as nth degree polynomial. That is why x to the power of n term should be there. Then only we can call this polynomial as nth degree polynomial or polynomial of degree n, right. So, this is what the definition of a polynomial, and we discussed about different types of polynomials as per the number of terms as well as per the degree. Okay. So, for example, what are the different types of polynomials as per the degree? Okay. For example, I have a polynomial p1 of x. p1 of x is nothing but this. What is this p of x? Like I have a name, you have a name, the other student has a name. The name of this polynomial is p of x. P stands for polynomial of x, means in terms of x. Suppose if I write a polynomial in terms of y, then I should represent this one as p of y. Okay. Now, p1 of x, I am taking one polynomial. That polynomial is like 2x plus 7. So, this is one polynomial. What is degree of this polynomial? The highest power is said to be the degree. There is only x term and whose power is equal to 1. That is why the degree of the polynomial is 1. Then it is said to be first degree polynomial. Otherwise, is there any other name for this first degree polynomial? Yes, it is said to be a linear polynomial. First degree polynomial or linear polynomial. Coming to second degree polynomial, for example, p2 of x, which is equal to like x square plus 2x plus 1. So, this is one polynomial whose degree is 2. So, that this polynomial is said to be second degree polynomial, Otherwise, is there any special name for this polynomial? Second degree polynomial, otherwise a quadratic polynomial. Second degree polynomial or quadratic polynomial. So, what do you mean by quadratic polynomial? If the degree of a polynomial is 2, then that polynomial is said to be a quadratic polynomial, right? And for example, taking one more polynomial which is in terms of x, that is x cube plus x square plus 1. X cube plus x square plus 1. What is degree of this polynomial? The highest power is 3. Since the highest power is 3, then this polynomial is third degree polynomial. Is there any other name for third degree polynomial? Yes, that is cubic polynomial. That polynomial is called cubic polynomial. Like that, another polynomial P4 of y, for example. Now I am going to write a polynomial in terms of y. This is x to the power of 4 plus 7. This polynomial is of degree 4. So, what is the name of this polynomial? You can call it as fourth degree polynomial. Otherwise, is there any special name for this fourth degree polynomial? Yes, it is said to be biquadratic polynomial. Fourth degree polynomial or biquadratic polynomial. Now, I have a question for all these things. See, this is a first degree polynomial, second degree, third degree, fourth degree. Are those polynomials in standard form or not? And what do you mean by standard form of a polynomial? Standard form of a polynomial means if a polynomial has all the possible terms in it, then it is said to be in standard form, otherwise it is not. For example, out of these 4 polynomials, which of them are standard form? See, 2x plus 7. Since it is a first degree polynomial, after first degree constant term should be there, means x to the power of 0 term is also there. That is why this polynomial is said to be in standard form, right? And x square plus 2x plus 1, this polynomial of degree 2, so that second degree term is there, first power term is there and constant term is also there. That is why this polynomial is also said to be in standard form. But whereas this third degree polynomial, x cube term is there, x square term is there, but x term is missing here. Since x term is missing, being a constant is also there, but missing of x term, that is why you cannot call this polynomial is in standard form, even though it is a third degree polynomial, but it is not in the standard form, right? And coming to x to the power of 4 plus 7, it is fourth degree polynomial, but third degree term should be there, second degree, first degree, constant. Of course, constant term is there, but 3 terms are missing in between. That's why you cannot call this polynomial as in standard form, right? So, this is about different types of polynomials as per their degrees. Now, we need to discuss about a second degree polynomial, okay, means a quadratic polynomial. Before that, we need to discuss about what is the value of x in the polynomial or what is the value of the variable in the polynomial. For example, there is a polynomial p of y which is equal to y minus 7. Y minus 7 is a polynomial, right? Now, I just want to know this polynomial value will become 0. I just want to make that polynomial is 0. Y minus 7 is equal to 0. How can I make that value of y minus 7 is equal to 0? That is only possible when you give some value to y, but not to 7, because 7 itself is 7, you cannot change the value. So that you need to give one value of y, that for how much value of y that y minus 7 is going to be 0? Yes, when you put y is equal to 7, then only 7 minus 7 is going to be 0. It means the value of the polynomial will be 0 for which value of the variable involved. That value of the variable to make this polynomial 0 is said to be 0 of the polynomial, right? So, now we are defining what is meant by 0 of a polynomial, right? Let us consider p of x is a polynomial, either it is first degree, second degree, third degree, fourth degree, whatever it is. For what value of this polynomial, for what value of the variable? For example, when x is equal to k, if p of k is going to be 0, then the value of x is equal to k is said to be 0 of the polynomial. In understanding a better way, that the 0 of a polynomial means for what value of the variable the entire polynomial will become 0, those value or values of the variable are said to be zeros of the polynomial. Why am I telling about 0 or zeros of the polynomial? Because since it is being a first degree polynomial, y minus 7 is equal to 0, then 7 minus 7 only equal to 0. There is no other value of y which makes y minus 7 is equal to 0. So that is why y is equal to 7 is only the 0 of this polynomial y minus 7 is equal to 0. Suppose if I take one second degree polynomial or a quadratic polynomial, okay. So my second degree polynomial is, for example, x square minus 3x plus 2. This is one polynomial. I can make this polynomial 0 for two values of x. They are, when I substitute x is equal to 1, then this polynomial will become 1 square minus 3 into 1 plus 2, which is equal to 1 square is 1 minus 3 plus 2. 1 minus 3 plus 2 is equal to 3 minus 3 equal to 0. Means the value of this polynomial is 0 for x is equal to 1. Therefore, one of the zeros of this polynomial x square minus 3x plus 2 is 1. And I have one more 0 of the polynomial, because I know that this x square minus 3x plus 2 will be 0 for one more value of x, that is x is equal to 2. If I substitute x is equal to 2 over here, then it is going to be 2 square minus 3 into 2 plus 2, which is equal to 2 square is 4 minus 3 2s are 6 plus 2, which is equal to 4 plus 2 equal to 6 minus 6 equal to 0. It means this polynomial x square minus 3x plus 2 has two zeros. One of the zeros is 1 and the other zeros is 2. I am pretty much sure that this polynomial has no other zeros. It has only the zeros 1 and 2. How would I know that 1 and 2 are the zeros of the polynomial? Am I really following trial and hit method? Not exactly. I know that x square minus 3x plus 2 can be factorized further by factorization method called splitting middle term method, right? If you factorize x square minus 3x plus 2, then multiply first number and last number is nothing but, after writing it in the standard form, multiply x square term in the constant, x square into plus 2 is equal to plus 2x square. Now you will have to split this plus 2x square into two terms such that their sum is going to be minus 3 and their product is going to be plus 2. For that you need to factorize 2. What are the factors of 2? 1 and 2 are only the factors. When you add 1 and 2, you will get 3. When you multiply 1 and 2, you will get 2. So that the factors of 2x square are 1x and 2x. But see here, the product is positive. When the product of two terms is positive, either both of them are positives or both of them are negatives. So can I put positive signs for both of them, or can I put negative signs for both of them? That depends on the sign of the middle term. Here the sign of the middle term is negative, so that I should put negative signs for both the two terms. So I am going to factorize this x square minus 3x can be written as the combination of these two, that is minus 1x minus 2x plus 2, correct? And from the first two terms I can take at the maximum x times x minus 1, and then minus 2 can be taken common, remaining x minus 1. Totally x minus 1 is the common factor and then remaining x minus 2, correct? These two are the factors. Now I can easily say that this entire term will be 0 when any one of them is 0. So x minus 1 is equal to 0. For what value of x minus 1, for what value of x that x minus 1 will be 0? You can easily guess that for x is equal to 1, x minus 1 will be 0, right? So x is equal to 1 is one of the zeros, right? And x minus 2 will be 0. For what value of x, x minus 2 will be 0? Yes, x is equal to 2. So like that, I was guessing the values of x to make this x square minus 3x plus 2 0. So that is why x square minus 3x plus 2 has how many number of zeros? 2 zeros. See here, y minus 7 is equal to 0. Y minus 7 is equal to 0 is a single first degree polynomial or a linear polynomial. What about the number of zeros of this linear polynomial? As it is linear polynomial, number of zeros is equal to 1. And now it is x square minus 3x plus 2. Since it is a second degree polynomial, can I say that every second degree polynomial has exactly 2 zeros? I will have to think about that, because for this x square minus 3x plus 2, I got 2 zeros. But if I take one more polynomial, for example, the polynomial is going to be x square p of x is equal to x square minus 4x plus 4. So, this is one second degree polynomial, right. P of x is equal to x square minus 4x plus 4, then if I factorize this x square minus 4x plus 4 by our splitting middle term method, then I get x square minus 2x plus 4. So, from the first two terms I can take x common, remaining x minus 2, minus 2 common, remaining x minus 2. So, totally I can write it as x minus 2 times x minus 2. X minus 2 times x minus 2 means x minus 2 whole square. So, this polynomial will become 0 only for x is equal to 2, but not for any other number. So, can I say that the number of zeros of the second degree polynomial is exactly 2? No, I cannot. So, here the number of zeros of this second degree polynomial here in this case is only 1, but in the previous case it is 2. But we cannot get more than 2 zeros of a second degree polynomial. That is why we can conclude here one thing, that if a polynomial of degree n, then what is the number of zeros of this polynomial and number of zeros of the polynomial of degree n? Then we should not say that this polynomial of degree n has exactly n number of zeros. We should say that this polynomial of degree n has maximum of n number of zeros, or more precisely at most n zeros. Okay, at most n zeros, but we should not say that it has exactly n number of zeros. Hope you understand my point, right. So, this is about 0 of a polynomial as well as number of zeros of a polynomial. Okay. So, finally, about the definition of a 0 of a polynomial is, let us consider a polynomial in terms of any variable. 0 of a polynomial means for what value of the variable or for what values of the variable the given polynomial will become 0, that value or those values of the variable are said to be zeros of the polynomial. And if a polynomial of degree n, then it has at most n zeros, but we should not say that it has exactly n number of zeros. Correct? Right. So, next we will try to understand about second degree polynomials, third degree polynomials and fourth degree polynomials in this class. Okay. So, let me take one second degree polynomial. Okay. So, what are second degree polynomials? If the highest power of any variable is 2, then they are said to be second degree polynomials. I am taking one second degree polynomial. Let us take p of x is equal to x square minus 5x plus 6. This is one second degree polynomial. And is it possible for me to draw this x square minus 5x plus 6 is equal to p of x on the graph sheet? For that, first let me guess about first degree polynomial. For example, the first degree polynomial is p of x is equal to some x plus 5. This is one polynomial. So, p of x is equal to x plus 5. Can I draw this p of x is equal to x plus 5 on the graph sheet? Then if I draw this on the graph sheet, then what it represents? Let me know that. So, p of x is equal to, for example, you take y, because this is the value of y, is equal to x plus 5. So, in order to draw this y is equal to x plus 5 on the graph sheet, I need at least 2 points, right. So, I am taking the points x and y. Okay. For example, I will take x is equal to 0. If I take x equal to 0, then 0 plus 5 is equal to 5, that is the value of y. And if I take x is equal to 1, then I get value of y is 1 plus 5 is equal to 6. I think these 2 points are enough to draw this. Okay. Now this is y-axis and this is x-axis. Okay. On x-axis I will take the values, as well as on y-axis I will take the values. What are these x-axis and y-axis? They are in fact number lines. X-axis is a real number line and y-axis is another real number line. That's it. Okay. Now x values are the maximum 0 and 1. So maximum is 1. So I will take 0 here and then 1 here. And what about the maximum value of y? 5 and 6 means 6 is the maximum, that too positive 6. So I don't want negative y axis. Okay. I will take the values, let it be 2, this is 4 and this is 6. Okay. Let me plot the points. When x is equal to 0, y is equal to 5. Okay. When x is equal to 0, y is equal to 5 means this is the first point. Okay. When x is equal to 1, then y is equal to 6. When x is equal to 1, y is equal to 6. So this is the point. You are aware of drawing this, right? And passing through these 2 points, you will have to draw a line. Okay. So if you draw a line, then it would be like this. So it represents a straight line. What it is? The name of the straight line is y is equal to x plus 5. So y is equal to x plus 5 represents a straight line on the plane, coordinate plane. So that is what is the position of this p of x is equal to x plus 5. It means every first degree polynomial represents a straight line. Every linear polynomial represents a straight line. Then what about the second degree polynomial? Let us try to understand now. What about the second degree polynomial, whether it represents a straight line or represents a curve or represents any other thing? Let's try to understand. Okay. So this is y is equal to x square plus 5 minus 5x plus 6. This is a second degree polynomial. Okay. And now I just want to draw this x square minus 5x plus 6 on the graph sheet. So since the degree is 2, I don't know how many number of points should I take. I will take at least 5 points. Okay. The values of x as well as the values of y. Now if I take x is equal to 0, then what about the value of y? See, 0, 0. P of x is equal to y now. So which is equal to y. So that when x is equal to 0, 0 and this is 0 plus 6. So 0, 0 and 6. Okay. I will take x is equal to 1. If I take x is equal to 1, then it would be 1 minus 5 is equal to minus 4. Minus 4 plus 6 is equal to plus 2. Okay. I will take x is equal to 2 now. If I take x is equal to 2, then it is going to be 2 square is equal to 4 plus 6 is equal to 10 minus 5 2s are 10, 10 minus 10 equal to 0. And then if I take x is equal to 3, then it is going to be 3 square is equal to 9, 9 plus 6 equal to 15, 5 3s are 15, 15 minus 15 is equal to 0. I will take one negative number. For example, this is negative 1. If I take negative 1, then it is going to be like, yeah. So negative 1 whole square is equal to positive 1. Minus 5 into negative 1 is equal to plus 5. So 1 plus 5 is equal to 6 plus 6 equal to 12. So when I take negative 1, it would be 12. Okay. So 1, 2, 3, 4, 5. I have taken 5 points. Now I am going to draw this on the graph sheet. So this is y-axis and this is x-axis. Okay. X-axis and this is y-axis. And of course this is origin. Now I will see what is the maximum value on x-axis. Maximum is 3 and minimum is minus 1. So I will take 1 centimeter equal to 1 unit. This is 1, this is 2 and this is 3. Of course I am taking one more, that is 4. And negative 1 on the left hand side of x-axis. So this is negative 1. Coming to the value of y, what is the maximum value of y? Maximum value of y is equal to 12 and there is no negative y, right? So I am taking this is 2 and 4 and 6 and 8 and 10 and 12. So taking 1 centimeter is equal to 2 units. I am going to plot these points now. So the first point is when x 0, y is equal to 6. When x 0, y is equal to 6. X 0, y 6. So this is my first point. And coming to the second point, when x is equal to 1, y is equal to 2. When x is equal to 1, y is equal to 2 is this point. And the third one, when x is equal to 2, y is equal to 0. X equal to 2, y is equal to 0. When x equal to 3 also, y is equal to 0. 3 and y is equal to 0. When x equal to minus 1, y is equal to 12. minus 1 and y is equal to 12 is this point. Now, if I closely observe these points, definitely these points will not form a straight line because they are uneven points. If they do not form a straight line, then obviously they form a curve. And then while joining these points, you be very careful. You will have to draw them with free hand. Okay. So, when you draw them with free hand, then the curve would be like this, and I will just join from here. Okay. It goes up and again it would be this. See, once observe this, what kind of a curve it is? Do you know what is the name of this curve? This kind of curves are said to be parabolas. Okay. So, this is a parabola, it is in the shape of U. Okay. It open upwards. X square minus 5x plus 6, that is the polynomial, and that is a second degree polynomial. So, every second degree polynomial represents a parabola. Okay. So, here the parabola open upwards. Sometimes the parabola will be like this. So, this would be the parabola. Okay. So, this parabola is said to be open downwards and this parabola open upwards, and moreover we will discuss about this, and moreover while observing this parabola intersecting x axis at two distinct points. What are those two distinct points? This is 2 and 3. At 2 and 3, this parabola intersecting x axis, right? And moreover, this 2, when you substitute 2 in the place of x, we got 0 as the value of the polynomial. So, can we say that this number 2 is 0 of this polynomial p of x? Obviously, because when you substitute x is equal to 2, then you got the value of the entire polynomial is 0. And again, when you substitute x is equal to 3, then the value of the polynomial became 0. So, that is why we can say one thing, that 2, 3 are zeros of the polynomial algebraically, like by factorization method. By splitting middle term method, we can easily figure out. But instead of factorization method, if you once observe from the curve, this curve or this parabola intersecting x axis in two distinct points. They are not only two distinct points, they are also called as zeros of the polynomial. Yes. So, where the curve intersect x axis, precisely x axis, not y axis. Where the curve intersect x axis, then that particular point on x axis, the value of x on x axis is said to be 0 of the polynomial. So, I can understand one thing from this curve. This curve is intersecting x axis at two distinct points. So, I can easily say that this polynomial has two zeros, and from this graph I can identify that 2 and 3 are two zeros of the polynomial x square plus minus 5x plus 6. Right. So, at what values of x on x axis the curve intersect, then those values of x are said to be zeros of the polynomial. Right. So, for example, if I have a curve, okay, the curve is like, see, my curve is, this is y axis and this is x axis. My curve is something like this. Okay, this is my curve. And I can easily say that how many number of zeros are there for this polynomial, and this polynomial is intersecting x axis in how many number of points? Yes, this is the first point, this is second point, and this is third point. So, my curve intersect x axis in totally 3 distinct points. Therefore, the total number of zeros of this polynomial is obviously 3. For example, one curve is like this. This is one curve, and how many number of zeros are there for this curve? We can say that there are no zeros of the curve, because this curve never intersect x axis at any point. If the curve is not intersecting x axis at any point, then there is no zeros of the polynomial. Understand? Whatever the degree of the polynomial, but it is not intersecting x axis at any point. For example, one curve is like this, that is, see, this curve is intersecting x axis in only one point. So, that the number of zeros of this polynomial is only 1, because that curve intersecting x axis or touching x axis in only one point, right. And one more graph is like this. Okay, this is the graph, and moreover, what is the number of zeros of this curve or number of zeros of the polynomial? See, this is the curve or this is the graph intersecting x-axis in only one point. So therefore, the number of zeros of this polynomial is only 1. So this way, graphically we can understand zeros of the polynomial also, right? So when you are given a graph and to obtain or to identify the zeros of the polynomial, just look on x-axis and at how many number of points the given curve intersect x-axis. Those points are said to be zeros of the given polynomial. Okay, this is about the graphical representation of polynomials. And one more thing is, every second degree polynomial or quadratic polynomial represents a parabola, and there are two types of parabolas. Those two parabolas are, what is the standard form of second degree polynomial? That is p of x is equal to ax square plus bx plus c. This is a standard form of second degree polynomial. Of course, a is not supposed to be 0. For example, if the value of a is more than 0, you have observed in the previous example, x square minus 5x plus 6. In that x square minus 5x plus 6, what is the coefficient of x square? That is 1. More precisely, that is positive 1. So if the value of the leading coefficient is positive, then the curve, the position of the curve will always be like this. What does it mean? It always open upwards. So if it open upwards, then you cannot say what is the maximum value, because it can be extended indefinitely in both the directions. But there is no maximum value for that, but we can easily understand what is the minimum value of the polynomial. So that in the case of a greater than 0, the parabola will be open upwards, and in this case we can find what is the minimum value of the polynomial, but we cannot find what is the maximum value of the polynomial. Similarly, if the value of a is less than 0, then the polynomial would be like this. This is the position of the polynomial. Position of the polynomial in the sense, it opened downwards, and there is only maximum value, but we cannot say that what is the minimum value of the polynomial. And you will understand everything briefly in +1 +2 about this maximum values, minimum values, and more about this first second degree polynomial and their curves. Okay, right. So this is about graphical representation of a second degree polynomial. Now coming to the number of zeros of the polynomial, and moreover, what is the relationship between zeros of the polynomial as well as their coefficients. Okay, I am going to explain this by taking one simple example, that is p of x is given as x square plus 7x plus 10. This is one second degree polynomial. I just want to know what are zeros of this polynomial. To obtain zeros of the polynomial, I need to factorize this second degree polynomial by splitting Milner method or by using any algebraic method. Okay. So x square into 10 is equal to 10x square. So the product is 10, and the sum of the factors is going to be 7. Therefore, what are the factors of 10? Yes, the factors of 10 are 2 and 5. I can say that x square plus 2x plus 5x plus 10. Okay. From the first two terms, I can take one x common and then x plus 2, and immediately I have plus sign, and from 5x and 10 I can take the maximum 5 common and then x plus 2. So totally I have x plus 2 is the factor and then x plus 5 is another factor. I can understand now here what are zeros of the polynomial. To obtain zeros of the polynomial, you can equate with 0, otherwise you can easily say that what are zeros of the polynomial. The product of two terms is equal to 0, either first term equal to 0 or second term is equal to 0, means x plus 2 is equal to 0, otherwise x plus 5 also equal to 0. If x plus 2 equal to 0, x is equal to negative 2, and x plus 5 equal to 0, x is equal to negative 5. Therefore, what are zeros of the polynomial? Therefore, zeros of p of x are, first 0 of the polynomial is -2 and second 0 of the polynomial is -5, right. So, this is the way of finding zeros of the polynomial. Now, my question is, when a polynomial either it is a second degree or third degree is given, then we know how to find zeros of the polynomial. But now the concept is, when zeros of the polynomial are given, then how to figure out that polynomial. Okay. See here, minus 2 and minus 5 are zeros of the polynomial. It was given. Okay. So, if minus 2 is 0, then what do you call this x plus 2? When minus 2 is 0, then x plus 2 is said to be factor of the polynomial. And minus 5 is 0, then x plus 5 is said to be factor of the polynomial. If you have two factors, to obtain a second degree polynomial, obviously you will have to multiply those two factors. So, when you multiply, you will get the standard form of that second degree polynomial. So, it is simply the converse of the method. Okay. You are given two zeros of the polynomial. Those two zeros are x is equal to alpha and x is equal to beta. Okay. These two are zeros of the polynomial. Now, I am going to figure out what is the quadratic polynomial whose zeros are alpha and beta. For that, I will just go in a converse way. That is, when alpha is a 0, then what is a factor? Yes, transpose alpha this side, then it is going to be x minus alpha is equal to 0. It means x minus alpha is a factor. Similarly, beta is a 0, I can say that x minus beta is a factor. When I have two factors, to obtain a quadratic polynomial, I need to multiply those two factors, right. So, then x minus alpha into x minus beta is equal to 0, because that is the product of two terms. Okay. When I multiply x minus alpha into x minus beta, I will get x square minus alpha into x is alpha x, minus beta into x is beta x, minus alpha into minus beta is plus alpha beta equals to 0. And if I write in standard form, I will get x square minus alpha x minus beta x. I can take one x common remaining, alpha plus beta, and then finally plus alpha into beta is equal to 0. This is what called quadratic polynomial equation whose roots are alpha and beta. But I want quadratic polynomial whose zeros are alpha and beta. Since it is a only polynomial, then equal to 0 should not be there. Then x square minus x into alpha plus beta plus alpha beta. So, this is what called quadratic polynomial whose zeros are alpha and beta. Now, I understand in both the ways that when you are given a quadratic polynomial, then understand how to find zeros of the polynomial. Conversely, when you are given zeros of the polynomial and how to form a quadratic polynomial whose zeros are given. Understand? So, x square minus x into alpha plus beta plus alpha into beta is called as the standard form of a quadratic polynomial when zeros are given, right. X square minus x into alpha plus beta plus alpha into beta. For example, by using this, I can easily find out what is the quadratic polynomial. For example, find a quadratic polynomial whose one of the zeros is 2 plus root 3. So, 2 plus root 3 is one of the zeros. Now, I am going to figure out what is the quadratic polynomial when one 0 is given. But see here, one 0 is 2 plus root 3, then other 0 is obviously its conjugate, okay, because it is an irrational number. Okay. So, 1 0 of the polynomial is given as 2 plus root 3, and according to the property of irrational numbers, the other 0 is going to be its conjugate, that is beta is equal to 2 minus root 3. So, what is the quadratic polynomial when two zeros alpha and beta are given? That required quadratic polynomial is p of x is equal to x square minus of alpha plus beta times x plus alpha into beta, right. When you substitute alpha is equal to 2 plus root 3 and beta is equal to 2 minus root 3 in this, then it will be it will become x square minus alpha is 2 plus root 3 plus beta is 2 minus root 3 into x plus alpha into beta. Alpha into beta is 2 plus root 3 multiplied by 2 minus root 3. Okay. Now you simplify to obtain a quadratic polynomial in the standard form, which is x square minus, you can cancel plus root 3 minus root 3. 2 plus 2 is equal to 4. So 4 into x is 4x, plus this is in the form of a plus b into a minus b. That would be a square minus b square, that is 2 square is equal to 4 minus root 3 whole square equal to 3, 4 minus 3 is equal to 1. This is our required quadratic polynomial whose zeros are 2 plus root 3 and 2 minus root 3, right. So this way we can easily find out what is the quadratic polynomial when zeros are given. And then suppose this is the quadratic polynomial x square minus 4x plus 1. Without actually finding the zeros of this quadratic polynomial, I just want to know what is their sum as well as what is their product. Did you get my point? You are given a quadratic polynomial and I am going to find what is the sum and what is the product of the zeros of the polynomial without actually finding the zeros. See, for example, 2 plus root 3 is one 0 and 2 minus root 3 is the other 0. Now I can easily say what is sum of zeros. Sum of zeros is equal to alpha plus beta. If I add both of them, I will get sum of zeros is equal to 2 plus root 3 plus 2 minus root 3. Plus root 3 minus root 3 cancel, 2 plus 2 is equal to 4. And what is product of zeros? So product of zeros is going to be alpha into beta. Alpha into beta is 2 plus root 3 into 2 minus root 3. Somewhere I found this, which is equal to 1. So this is sum of zeros and product of zeros. I figured out them by multiplying as well as by adding the given zeros. But here the point is, I am not given the zeros of the polynomial, but I am going to figure out what is the sum as well as what is the product of the zeros. Is it really possible for me? Let me think. How to find sum of zeros as well as product of zeros. Okay, right. For that, I am going to take the standard form of the second degree polynomial, that is p of x is equal to ax square plus bx plus c, right. And moreover, the zeros of this polynomial, let us consider the zeros of this polynomial are alpha comma beta are zeros of the polynomial. Okay. And moreover, I know what is the polynomial whose zeros are alpha comma beta exactly, right. So the polynomial whose zeros are alpha comma beta is x square minus of alpha plus beta times x plus alpha into beta. This is what exactly the polynomial whose zeros are alpha and beta. But what was given? Alpha and beta are zeros of ax square plus bx plus c. So it means according to the information given, both the polynomials are same, right, because alpha beta are zeros of ax square plus bx plus c as well as alpha beta are zeros of x square minus of alpha plus beta into x plus alpha beta. Then I can definitely equate both of them. But beforehand, when I equate this polynomial with this polynomial, here the coefficient of x square is 1, whereas the coefficient of x square is equal to a. So that is why I am going to do one thing, p of x is equal to 0. When I equate p of x with 0, then it would be ax square plus bx plus c is equal to 0. In fact, this is same as x square minus of alpha plus beta times x plus alpha into beta. Okay. Now I am going to take one a common, otherwise dividing every single term by a. Both are same. So I divided by a, and this is also by a, this is also by a, this is also by a. Then it is going to be ax square by a would be x square plus bx by a would be b by a into x plus c divided by a is going to be x square minus of alpha plus beta times x plus alpha into beta, right. Since these two are same, two second degree polynomials are same, then their corresponding terms are same. Corresponding terms means x square term is equal to x square term, x term is equal to x term, constant is equal to constant. See here, x square is equal to x square, they are same already, and comparing x term to x term. So when I am comparing x terms, here the x term is b by ax, means b by a. Here the x term is minus of alpha plus beta, right. So b by a is equal to minus of alpha plus beta. Here I can say that the value of alpha plus beta is equal to minus b divided by a. It means to find out sum of zeros of the given polynomial, I just consider the ratio between b and a. What is that b there? B is equal to coefficient of x divided by a. What is that a? Is coefficient of x square. Okay. So alpha plus beta is equal to minus b by a. That is the standard formula for finding sum of zeros of a second degree polynomial. Okay. Now going to compare constants. So here the constants are, first constant here it is c divided by a, there the constant is alpha into beta. So what does this mean? The product of zeros alpha into beta is going to be c divided by a. So with this I can understand one thing, that without actually performing zeros of the polynomial, I can easily figure out what is the sum of the zeros by using alpha plus beta equal to minus b by a, as well as product of zeros alpha into beta is equal to c by a. So please do remember the formula for sum of the zeros as well as product of the zeros of any second degree polynomial which is in the form of ax square plus bx plus c. Sum of zeros alpha plus beta equal to minus b by a, and product of zeros alpha into beta is equal to c divided by a. Here minus b by a is nothing but minus b. B is equal to coefficient of x divided by a is equal to coefficient of x square. Okay. And product of zeros is equal to c divided by a, where c is constant divided by a is equal to coefficient of x square. Okay. So you will have to remember these two formulas, and this is what is also called as the relationship between zeros of a polynomial as well as their coefficients. Okay. The relationship between zeros and coefficients of a polynomial. For example, you are given one problem, that is find out zeros of the polynomial and also verify the relationship between zeros and coefficients of a polynomial. Okay. So the problem here is find out zeros of x square minus 17. You will have to find out zeros of this polynomial x square minus 17, and hence verify the relationship between zeros and coefficients. So how to find out zeros of the polynomial x square minus 17? That is the first task. And then verify the relationship between zeros and coefficients. Let us try to understand the first task, x square minus 17. Okay. So here the given polynomial is anyway in terms of x, so that I am considering the given polynomial as p of x is equal to x square minus 17. Right. I am going to find out the zeros of the polynomial. To find out zeros of the polynomial, definitely I will have to factorize this. But how do I factorize this x square minus 17? Since it is having only two terms and the first term is being a square number, then to identify and to compare this with a square minus b square, second number should also be a square number. How do I make this 17 as a square number, and how much whole square is equal to 17? Then it is going to be x square minus square root 17 whole square. Now it is in the form of a square minus b square, and the formula for a square minus b square is a minus b times a plus b. Okay. So, these are factors of the polynomial. Now, I am going to find out zeros of the polynomial. To find out zeros of the polynomial, let p of x is equal to 0, because I am going to make it 0. So, when the product of two terms equal to 0, either first term equal to 0 or second term is equal to 0, means x minus root 17 equal to 0 or x plus root 17 equal to 0. If x minus root 17 equal to 0, x is equal to root 17, means root 17 is one of the zeros. And similarly, x plus root 17 is equal to 0, then x is equal to negative root 17. So, I got what are zeros of the polynomial. Therefore, zeros of the polynomial are zeros of p of x are, generally we indicate zeros of the polynomial by alpha and beta, right. So, that alpha is equal to square root 17 and beta is equal to minus square root 17. So, my first task is done. And what is the second task? And hence verify the relationship between zeros and coefficients. So, in order to verify the relationship between zeros and coefficients, I need to compare the given second degree polynomial with the standard form. Okay. So, that is the second part of the problem. Okay. I am writing it as second one and this is the first one. Okay. What is that given polynomial? X square minus 17, but x square minus 17 is not in the standard form because x term is missing there. So, that is why I am writing this as x square plus 0 into x minus 17 with the standard form ax square plus bx plus c, right. Now, I am going to verify the relationship between zeros and coefficients. First of all, sum of zeros of the polynomial. Sum of zeros is equal to alpha plus beta. Just now we obtained one formula for sum of zeros alpha plus beta. Have you remembered that? Yes, that is minus b divided by a. That is sum of zeros. Substitute the values. The value of alpha is equal to root over 17 plus beta is equal to minus root over 17, which is equal to minus the value of b. What is b here? When you compare them, a is equal to 1, b is equal to 0 and c is equal to negative 17. So, that b is equal to 0. So, minus 0 divided by a is equal to 1. 0 by anything is equal to 0. But what is root 17 minus root 17? This is 0, which is equal to 0, right. So, sum of zeros is verified. Now, second thing is product of zeros. And coming to product of zeros, what is the formula for product of zeros? Alpha into beta, which is equal to c divided by a, right. The value of alpha is equal to square root 17 and beta is equal to minus square root 17 is equal to c divided by a. The value of c is going to be minus 17. So, minus 17 divided by a is equal to 1. So, here root 17 into root 17 is equal to root 17 whole square, which is equal to 17 and minus is there. So, minus 17 which is equal to minus 17 by 1 is minus 17. Minus 17 is equal to minus 17. Therefore, product of zeros also verified. So, finally, we verified the relationship between zeros and coefficients. So, this is the way of finding zeros of the given polynomial as well as verifying the relationship between zeros and coefficients, right. Yeah. Coming to the next example is going to be when you are given two numbers as one of them is sum of the zeros and the second number is the product of zeros. And then what is the quadratic polynomial whose sum of zeros as well as product of zeros are given. Okay. I will explain by taking one example. That is, find out a quadratic polynomial. Find out a quadratic polynomial whose sum and product of zeros are minus 1 comma 3 divided by 4 respectively. So, here the numbers are minus 1 comma 3 divided by 4. So, minus 1 comma 3 divided by 4 are the numbers, and what kind of numbers they are? Minus 1 comma 3 divided by 4. See, these two are alpha and beta or anything else. These two are not alpha and beta. If you understand the problem clearly, find out a quadratic polynomial whose sum and product of zeros, means the first number represents sum of zeros and the second number represents product of zeros, but they are not zeros, right? So that you will have to understand the only point from the problem, that is what is given here, sum of zeros. Sum of zeros is given, that sum of zeros is equal to alpha plus beta, that was given as minus 1, and then product of zeros is given as alpha into beta, which is equal to 3 divided by 4, and you are asked to find out what is the quadratic polynomial. So then the quadratic polynomial whose zeros are x comma alpha comma beta is x square minus of alpha plus beta times x plus alpha into beta, right? And now x square is x square minus alpha and beta are not given, alpha plus beta and alpha into beta. So that directly you can substitute minus 1 in the place of alpha plus beta into x and 3 by 4 in the place of alpha into beta plus 3 divided by 4. So finally, the polynomial is going to be x square minus of minus is equal to plus 1 into x is equal to x plus 3 divided by 4. Suppose if you don't want fractions in the given or in the polynomial so obtained, then you take the LCM. Then it is going to be 4x square plus 4x plus 3 whole divided by 4. So you can write this one as 1 divided by 4 times 4x square plus 4x plus 3, or else simply you can write this polynomial as 4x square plus 4x plus 3 as per the zeros, because if you find zeros of this polynomial or zeros of this polynomial, then both the zeros must be same. So that is why you can write any one of these two polynomials. So this is the way of obtaining a quadratic polynomial when sum of zeros as well as product of zeros are given. So hope you understand how to form a quadratic polynomial when zeros are given and how to establish a relationship between zeros and coefficients of a quadratic polynomial. So please do remember the formula for finding a quadratic polynomial when the zeros are alpha and beta are given is x square minus x into sum of the zeros plus alpha into beta, that is the product of the zeros. Okay, and what is the formula for sum of zeros of a quadratic polynomial ax square plus bx plus c? That is alpha plus beta equal to minus b by a, means minus coefficient of x divided by coefficient of x square. And what is the formula for product of zeros? That is alpha into beta is equal to c divided by a, which is constant divided by coefficient of x square, and we discussed a few set of examples also on the same concept. So hope you understand. Thank you.